I decided to try and make one of those electromagnetic vices. We've seen online other people have done it. It's just a couple of transformers from microwaves. All you do is cut along the weld line where the two pieces are joined and knock them apart, and then to cut them down to size, I just put them in the bandsaw. Worked pretty well. It's just a case of wiring them up, testing it, and then filling it with epoxy. So I'm just going to wire it up for now before I pour anything and see if it actually works. But it's pretty simple. It's just a metal box made from pieces of plate, and just weld it in enough to hold it and to stop the epoxy from leaking out. I've got a power indicator here. I'll put a switch here. I was going to use this, but then I thought, hang on, I mean, oil and stuff is going to get in it, and it's not really designed for it, so I bought an IP56 type switch, which is kind of sealed, and I'll use that instead. Anyway, I'll wire it up, see if it works, and if it does, I'll fill it with resin. Well, it turns out, I've been looking at the videos on YouTube, and they all imply that just connect the 240 volts to the transformers and away you go, which, I mean, they're normally connected that way, but I think with the other winding and the full coil of plates around it, it controls how much current is going through. But if you just connect it straight to 240 volts, within a few seconds it just starts smoking and burning. So you really need a DC source, and I'm just running a small car battery charger on it at the moment, and that is reasonably, I can't pull that off easily, and that's only like 3 amps, so I'm going to fill it with epoxy and come up with some sort of a bigger power supply. I think I just need a small AC transformer with a little bridge rectifier, or even maybe a converted power supply, but it definitely needs DC. But I think it's going to work okay for a drill press vise. There we go. You can hear it humming when it's all bridged. I've got them in series, the two coils, so that effectively increases the resistance. I could try it in parallel and probably get a bit more current through and a bit more power, but I'd rather do that by increased voltage and current. But potentially, all you do, up it comes. It's awesome. So here it is. I've filled it with epoxy. I had a couple of leaks because there was a hole here and I put a plate over it, but it leaked through the plate. So, a bit of a mess. But not that much leaked over, and I topped it up and had a bit more overflow on this side, but not much. But I've still got to clean that all up, and I've still got to obviously machine it down and machine it completely flat. There's about 5 mil or so that I can take off, so I'll put that in the vise and face mill both sides. But at the moment it's just being powered by this little power supply that's temporarily rigged up. I can't use this permanently because it gets too hot. I need to have some sort of current limiting on it. It's okay for about 10-15 minutes, but I'll probably hack the computer power supply or something like that, or just build a new one with a current limiting circuit on it. But this is what it looks like. Have I turned it on? No. Righto. So it's on, and there we go. It's a bit weak purely because of the height of the polyurethane above the actual coils. As I said, when I machine it, it'll be much stronger, and I was actually able to lift the whole thing up with a piece of steel before I filled it with epoxy. So once the machining's done, it should be good to go. Then it's just tidy it up, even out the ends, and use it. Anyway, it was an interesting little side project. Well, I'm machining the top flat of the electromagnetic vise, and what a mess. It's Christmas time at the mill, as you can see. Holy crap. Anyway, so here it is. I've been machining it. It's going pretty well. I'll take about another, I don't know, about maybe 0.5 millimeter off it, smoothen it all out, and then I'll flip it over and try to work out a way to machine the other side. It's not going to be to any high standards of the two sides being parallel, but it's going to be more than good enough for a drill press. So anyway. So I was trying to work out how to clamp this thing so that I could just clean up the underside without, well, clamping it in a way that I could machine the whole surface. I've got these ears for when you clamp it the right way up, but I was trying to work out how to clamp it this way, and then I realised, of course, that it's an electromagnet, so switch it on and you can just machine. It only just occurred to me. Just a bit of footage to show it's actually holding itself in there really nicely. It hasn't moved at all. I'm only taking light cuts, but this is exactly what this sort of vise is for anyway. It's just for thin, flat stuff to be able to clamp it down and machine it without trying to worry about how to set it in the vise. It's working well. Not a bad little proof of concept, really. So here it is. It was, sorry, there it is. It was a fun little exercise. Does it work? Yeah, it does. I'll just turn on the magnet, and you can't, there you go, it's strong. Will it last? Probably not. I will rig up some sort of better power supply that doesn't just give it as much current as it wants, because it does get warm, although it's not hot. What have I learnt? Most important thing is, don't run your power cables through the center where you want to put a hole if you're going to be using it as a drill press vise. That was stupid. I'll probably just drill a little bit to the side, but that was just dumb. I moved them at the last minute, and something was bothering me about why they shouldn't go there, and now they're in. It was a good quality switch, but it lasted 5 minutes. It's basically plastic with a chrome sleeve, and it snapped off, and probably because some of the polyurethane must have gotten in there, and it was, I mean, it felt alright, but if there's any reason I think it would have broken. Luckily, I mean, it broke in the on position, but it doesn't really matter. You can get in there with a screwdriver and flick it if you need to, but I'll just switch it off and on the power point, or even put in a switch in line with the cable, maybe with an indicator light, because the other thing that happened was that the indicator lights become flaky. It's an LED, and the lesson there is, don't encase your switches and your indicator lights inside the epoxy resin. Once it's in, it's in. But as a proof of concept, and as something to knock together that, well, is very cheap, I had the metal, I had to buy the switches, but yeah, 2 microwaves that were thrown on the verge outside on the major strip. I just stripped them there and then took out the transformers and threw them back on the pile of junk. So the epoxy resin cost a bit, but that was a useful exercise. I've never used it like that before, and it was a good little way of having a practice run with it. It's nice stuff. And my welds were pretty good on the inside as far as leaks go. As I said, I'd put a plate here to cover that hole, but the best thing would have been to have put some silicone around this hole, and possibly a little bead of silicone all the way around inside, just a little bead, just to stop any chances of leaking, and then put it somewhere raised off the ground so that you've got to overfill it, whatever runs off. At least it won't stick to the bench or anything like that and won't make a big mess. What was the other thing? There's one other thing with the epoxy resin. I forget. Maybe it'll come to me. So Yes, you do need to overfill it. That's right, and you need to cut off any excess before it fully cures. It cuts off pretty easily if you wait till it's fully cured. It's difficult. So I'll try using this. I'll probably clean it up, maybe give it a coat of paint. I will get a better power supply because again I can do that pretty easily. But oh well, proof of concept. It works. Just remember, don't use AC, use DC. Whee! There we go. So here it is. A little bit more paint will help, but essentially it's done. It works great. I've just modified a computer power supply to give 12 volts at, I don't know, 8 or 9 amps to run it. Costs you nothing because there's so many of these being thrown out. If you look at Great Scott's YouTube channel, Great Scott Power Supply, if you search for that, you'll see how to make these. They're pretty simple. So basically, you can see if I switch it on, yeah, and then using a fair bit of force there. The vise itself needs to be clamped to the table. I haven't done that yet. I've got to make some quick release way of doing it, but it's heavy enough that for something like this, it's not necessary. There we go, we're through. Turn that off. Switch that off. Take it away. I've just got to drill a hole in the center of it and avoid those cables I stupidly put there. I'll just offset the hole slightly, but there we go. Worth doing.